we'll take the panel and label it as phospholipids and proteins in a biological membrane. So again, we'll use this pattern of having the phospholipid head groups lined up side by side. And then the fatty acid side chains. So again, the side chains will be facing one another. And the head groups will be facing out toward the water. And this extends on at this dimension for hundreds of meters. Because typically the distance that we see with these two phospholipid bilayers is in terms of 6 to 7 nanometers. This is really small. The head group itself is in terms of a 1 to maybe as much as 2 nanometers, closer to 1. A nanometer now is 10 to the minus 9th meters. It's a millionth of a millimeter. We're down to molecular kinds of distances. So we're talking about things being really, really small. And if you imagine this is 1 to 2 nanometers, and here I have it as 3 or 4 centimeters, I'll let you do the scaling, but this is going to make this thing go on for miles. But it doesn't take too much of a stretch from what I've drawn here to imagine that we can describe a kind of sidedness to this. We can describe this as water on the outside, and we can describe this as water on the inside. And from that, it's not too much of a stretch to imagine this is the outside of a cell and this is the inside of a cell. But if you spend a moment looking at this, you'll see that what we have generated is a pretty significant palisade, a pretty significant barrier to the movement of charged particles. Sodium, potassium, chloride, from one side of the palisade to the other. So this barrier, in fact, does separate the inside of a cell from the outside of the cell. This is the phospholipid portion of the lipid mosaic model of the membrane. So we can, again, spell this out as the phospholipid of the lipid mosaic model of the membrane. The term mosaic, in fact, means that punctuated through these regions now we'll see proteins that extend from one side of the membrane to the other. This thing I'm drawing in orange that looks like a hot dog bun, this is meant to be a transmembrane protein. And throughout these phospholipids, we will see a whole variety of transmembrane proteins. So now we can think of this as a sea, a two-dimensional sea of phospholipids, punctuated, made to be a mosaic by the proteins that are crossing the lipid bilayer. It's these proteins that extend across the phospholipid bilayer that provide pathways of communication. Across the bilayer. I should say phospholipid bilayer. So what we've done here is we've worked our way through the structure of phospholipids. We've talked about how the phospholipids will organize themselves with respect to water in a monolayer, either as on the surface or as a micelle. We then generated a phospholipid bilayer to generate stability and talked about that in terms of a liposome and extended that liposome out to a planar structure punctuated by the transmembrane proteins.